everyone, welcome to the channel. So here we are discussing the question binary minimal on Codechef. So the problem states that Alice is given a binary string s of length n. She can perform the following operations on string s. Select an index I ranging from I to length of s and delete the character si. Select an index I ranging from 1 to length of s and flip the character si. So flipping means 1 becomes 0 and 0 becomes 1. So we need to find the lexicographically smallest string Alice can obtain using at most k operations. Note that string x is said to be lexicographically smaller than string y if string x is a prefix of string y, or the smallest index I where x and y differ, xi is less than yi. So here we have input as t, the number of test cases, and test case contains of n and k, which denotes length of string and maximum number of operations. And next line contains the binary string s of length n. So we need to create a lexicographically smaller string. Let's look at the inputs. So first of all, we have input of 0, 0, 0 and k equal to 1. So you can perform any one operation, and already you have all the zeros. So we will remove 1 0 from here and the answer will be 0 0. In case of 2 0, you have 1 1, but you can't flip 1 because there are 0 number of operations possible. Hence the answer is 1 1. Now let's take the case of 1 0 1 where you have only one operation. So if you have only one operation, you will convert it to 0 0 1. Suppose if you have two operations, then what you will do? Convert it to 0 0 0. But now if you have three operations, then you will remove this 0 as well and your answer will be 0 0. So like this we need to reduce. Now let's take another example where I have 1 0 0 0. Now I have 1 at starting index, so I can remove this 1 if I have only one operation. So my answer is 0 0 0. So we got the solution. Now what we need to do is we will first count the number of 1. So in this case let the count be 1 because we have 1 triple. Now here my count is 1 and my k is also 1. So what I will do, if my count is less than or equal to k, I will remove the k elements because all I can do is turn all the ones to zeros. So if count of 1 is 3 and my k is 5, suppose I have here 3 ones and my k is 5, so I can remove the extra zeros also. So I will remove all these 5 elements. So my answer will be n minus k times 0. So for n minus k, you have k as here 5 and my n is 6. So 6 minus 5, which gives me 1. So I have 1 0 as my answer, as you can see here. In 5 operations, what I am doing? First I am converting these two, like removing these ones and then removing these zeros. So I am left with this one. Now in case if I have these 3 ones only, let's take the same example, 1 1 1 0 0. So I have 3 1 and 3 zeros, but now instead of number of ones, let number of ones be 5 here and k is 3. Now since number of ones are 5 and k is 3, what we will do, we will start from the starting, and from starting wherever we encounter 1 we will turn it to 0. So for 3 operations we will turn it to 0, so it will become 0 0 0 1 1 0 0 0. So this will be my answer. Hence we have two cases. One case is where count of 1 is greater than k. If it is greater, we will replace ones with zeros. Else, if it is smaller than or equal to, then we will remove that number of ones and also we will remove zeros. In short, we will remove the k elements from the start. Or you can say if I have 1 0 1 0 and I have number of operations, say 2, k is equal to 2, so I will have 2 zeros as my answer, which is true because I can remove both of them. So hence this is the solution to the problem. Now let's look at the code. So this is the Python code for the problem. What we are doing, we are counting the number of ones. If count of ones is less than equal to k, then our answer is 0 into n minus k, which means 0 repeated n minus k times, as we discussed. And if this is not true, which means our count is greater than k, then we will replace ones with zeros and then decrement k till k is greater than 0. We will replace ones with zeros and then afterwards print that string. So this will be our answer. And as you can see, it passes all the tests. So I hope you all understand this solution and got the approach what we are trying to do. So this is the whole code, and you can also try run using the statements which I use. Suppose the example of 1 triple 0. In this case, if I have k2, so count of 1 is 1. 1 is less than equal to 2 obviously. So you will have 0 into n minus k. 0 into n minus k gives us 2 zeros. And that is our answer, because in two operations we can remove this and as well as remove this. Our answer is 0 0. So I hope you all understand this intuition as well as the code. Thanks for watching.